Okay, so here is question number 7. This is quiz number 4, chapter 4, part 2. So, quiz, oops, got the U there. Quiz 4, part 2, question 7. Find the probability that when a couple has 3 children, at least one of them is a boy. At least one of them is a boy. Okay, and assume the boys and girls are equally likely. Okay, this is an at least one question, right? How do we do at least one? We had a formula. It's 1 minus naught, whatever they asked, times naught, whatever they ask. Times again, there's 3 children, so times the third time, naught, whatever they ask. So you do it that way. So, okay, so that's the formula. I want to put that on your 3x5 card or your full sheet of notes for the next exam. So 1 minus naught what? What are they asking for? At least one of the 3 is a boy. So naught boy times naught boy times naught boy. Why 3 of them? Because we're saying 3 children. One of the 3 children. So that's 1 minus. What's the chance the first child's not a boy? 0.5. How do I know that? Assume that boys and girls are equally likely. 50-50. 50% chance. So each of those is 50. Not boy, not boy, not boy is 50%, 50%, 50%. So use your calculator. Literally just type in 0.5 times 0.5 times 0.5. I'm getting 0.125. 1 minus that, I'm getting 0.875. And there's the answer. The probability is 0.875 that the family is going to have at least one of the 3 children as a boy. It's likely. You'd expect it. It's likely that they're going to have at least one boy if they have 3 children. And if they want a fraction, I think they might want a fraction on this one. If they want a fraction, on your TI, you just hit, to turn a decimal answer into a fraction, you hit math. Hit the math button on your calculator. The math button is located on the left side of your TI calculator, up near the top, just below the blue and green buttons. You'll see the math button. Hit the math button and then just hit enter twice. That'll change any answer to a fraction, and that'll change it to 7/8. That's the fraction. That's the decimal 0.875 is the same as the fraction 7/8. You just hit the math button, which is on the left side of the calculator, up near the top, right below the blue and the green buttons. Math, enter anytime you want. It'll take a decimal and change it to a fraction. All right, let's go on to number 8. So they give me this table over here of, so this is the individual. Let's make sure we understand. The individual actually had the disease, yes or no. And over here, this is the test result, was positive or negative test result. So, for example, these 121 people, they actually have the disease and they tested positive. The test said they have the disease, and they do have the disease. These 39 people, they have the disease. It's a yes, they have the disease, but the test came out negative. The test said they did not have the disease, but they really do have the disease. These 5 up here, they do not have the disease, but the test was positive. The test said they do have the disease. That's a false positive. The test said they have the disease, but they don't. This group down here was a false negative. It said they don't have the disease, but they really do. And then finally, these 135, the test said no, and they don't have the disease. So they don't have the disease, and the test said no. All right, so that's what that table's saying. Let's go to the question. What's the question? Find the probability of getting someone who tests negative, given that given's a big word, given that he or she did not have the disease. Okay, so how do we do given probabilities? We always do those. The denominator is always the given, because it limits what's possible. So they're saying, hey, we grabbed somebody at random out of this whole group. We grabbed somebody at random and find the probability that it's someone who tested negative, given, here's what we know, he or she did not have the disease. They're giving us that fact. They're telling us he or she did not have the disease. They're giving us that. They're saying, hey, by the way, I picked somebody out of the group, and they did not have the disease. What's the chance that they also tested negative? That's what they're asking. So the chance of a tested negative given did not have the disease. That's what they're asking us. So you notice I put the given is on the bottom, because that's the group we're talking about. We're talking about somebody who did not have the disease. How many people did not have the disease? All those people. 5 plus 135. In other words, 140 people. And how many out of these, all these people that did not have the disease, we're talking about a person from that group. That's what's given. That's what we know for sure. It's somebody out of that group. It's somebody that did not have the disease. What's the chance they were somebody that tested negative? 135. 135 of those people tested negative. So 135 out of 40. Divide that on your calculator. I'm doing that right now. I'm getting 0.964 rounded to 3 decimal places. 0.964. Okay, the next question, number 9 now, it's virtually the same thing. Same kind of table. Did the subject lie? It's a lie detector test, polygraph test. These tests are not perfect, just like medical tests are not perfect, although they generally tell us the truth. Did the subject lie? Tell me about these 13 people. No, they did not lie, but they got a positive test result, meaning the polygraph said they were lying. So that's a false positive. They weren't really lying, but the polygraph said they were. They were just nervous, I guess. These 35 were not lying, and the polygraph said they were not lying. These 41 really lied, and the polygraph said they were lying. So it was telling us the truth. And these 12, they lied. They're under the yes lied, and it said they did not. So that's a false negative. They got away with something. They were lying, and the polygraph machine said they were not. They tricked the machine. Okay, so let's come back and answer the question. Find the positive predictive value for the test. That is, find the probability that the subject lied. So we want lied. Given, there's that given word. The given always goes in the denominator. Find the probability they lied. Given what? The test came out positive. So positive test result. So what's the chance they lied given it was a positive test result? So we're talking about people that got a positive test result. What's that? That's all these people, huh? All those people got a positive test result. So that's 13 plus 41. Among all those people, how many of those people lied? Did not lie, lied. 41. 41 out of those people. So what's that? That's 41 divided by 54. Divide that on your calculator. I'm getting 0.759. 0.759. That's the 3 decimal place answer on that one. So what does that mean? That means 75, basically 75.9, so 76% of the people who got a positive test result actually lied. So so 76% of people who get a positive test result, meaning the lie detector test says they're lying, actually are liars. 76% of them actually are liars. So it's not a perfect test. Number 10. To reduce laboratory costs, water samples from 5 public swimming pools are combined for one test for the presence of bacteria. Further testing is done only if combined samples test positive. So do you get what they're saying? They take samples from 5 swimming pools and they combine them into one test, one big dish. They pour samples from 5 swimming pools into one big dish to test for the presence of some bacteria in the water. And they only do further testing if it comes back positive. Based on past results, there is a 0.007 probability of finding bacteria in a public swimming pool area. Find the probability that a combined sample from 5 public swimming areas will reveal the presence of bacteria. Okay, that can be a pretty confusing question. Let's think about that. What they're really saying is, come down here, find the probability that, one more time, was it find the probability that a combined sample from 5, so find the probability that combined sample from 5 pools equals positive. That's what they're saying. Combined sample from 5 swimming areas reveals bacteria. Positive for bacteria. Okay, well, how's that work? So they're gonna pour the 5 samples into one test, in one combined sample, and test it. So that means if there's bacteria in any of the 5 swimming pool samples, when they're all combined into one sample and tested, it'll come back positive. So they're saying, what's the chance that the combined sample will come back positive? Well, that's the same thing as saying the probability that at least one pool is positive. Right? Because if at least one of the pools, if at least one pool has bacteria in it, when you combine the samples, it'll come out positive. So at least one pool positive, I should say. So if at least one pool is positive for bacteria, if one or more of the pools is positive for bacteria, then the whole combined sample will be positive. So that means it's an at least one question. We know how to do at least one. At least one, how do you do at least one? 1 minus naught, whatever they're asking, times naught, whatever they're asking, times naught, whatever they're asking, times naught, etc. Well, and how many of these do we do? 5 of these, because there's 5, so I can do it this way to make this more quick and convenient. Just do that to the 5th power. So it's going to be 1 minus naught whatever they're asking. What are they asking? At least one pool positive. So not positive to the 5th power. 5th power because there's 5 in this 5 pools in the one combined sample. Right? That's how at least ones work, right? We take at least one, it's 1 minus naught times naught times naught times naught, 5 times. So we just do 5th power here. And so that's 1 minus, now, not positive. What's the probability that one of them is not positive? Well, right here, it says 0.007 is what? Based on past results, there is a 0.007 probability of finding bacteria in a pool. That's the probability of positive for bacteria is 0.007. So that's the probability of positive. So then what's the probability of negative? What's the probability of not positive? It's going to be 1 minus 0.007. It's going to be, your calculator will tell you 993. So that's the chance of not positive. That's the probability of one sample. That's just one sample. This is the probability of one sample. So I hope I'm not confusing you, the difference between one sample and then all 5 samples combined. So the probability that one sample is positive, as they're saying here, based on past results, there is a 0.07 probability of finding bacteria in a public swimming area, just one. So the probability of one sample being positive is 0.007. So the probability of one sample not being positive, being negative, is 1 minus that, 0.993. Well, that's what we have right here, 0.993. Right? The probability that one sample is not positive to the 5th power. That's what you're supposed to do for at least one. For 5 combined, that's at least 1. If you have 5 combined, you want at least 1 to come back positive. At least 1 is always 1 minus naught times naught times naught times naught. So 1 minus naught to the 5th power, not positive. The probability that 1 is not positive, 0.993, to the 5th power. So hit the buttons on your calculator, 1 minus 0.993 to the 5th power. And how you type that in, let me write that up here for you. On your calculator, 1 minus 0.993, bring it up here for you. To the power, you have an up arrow button, which is in the right side of the calculator. Up arrow, that's your power button. So on the right side, right below the up, down, right, left arrows, right below the clear button, up arrow 5 equals, or enter, I mean. So that'll take it to the 5th power. Or you could just multiply the 0.993 times itself 5 times. That's what it means. Right? It means 0.993 times 0.993 times 0.993 times 0.993 times 0.993. Right? 5 of them. 1 minus naught, 5 swimming pools. And when you do all that, the answer you get, calculator's telling me, I'm getting 0.03. They want what, 3 decimal places? 0.0345. Oh, actually, that's too far. So 0.035, right? Round. This is the 3rd decimal place. Look 1 to the right, 5 or more go up. So 0.035. 0.035 is the probability of that. Now, they have a follow-up question. Is the probability low enough so that further testing is rather safe? Is that pretty low? Yes, that's pretty low right here. Answer C. The probability is quite low. That's only a 3% chance. That's very low, indicating that further testing will rarely be necessary, right? Because they test the whole batch of 5. That's a way they can save time. If they just dump all 5 into one combined sample, even then the chance is only 3%, 3.5%, that the sample is going to come out positive. So most of the time it's going to be negative, and that'll mean all 5 pools have no bacteria in them. It's just a quick way to speed things up. If the whole sample comes out negative, which happens most of the time because the sample comes out positive only 3.5% of the time, most of the time it comes out negative. If it comes out negative, then you know all 5 swimming pools are negative, no bacteria in them. Whereas if it comes out positive, then you got to go back and test each of the 5 to find out which one, or maybe more than one, has bacteria in it. But most of the time, it comes back negative. Only 3.5% of the time does it come back positive. So that's very rare. Most of the time, this will save you time. There we go.